Imagine a world where computers can solve problems that would take today's fastest supercomputers billions of years to crack. Welcome to the future of quantum computing. Today, we're diving into the mind-boggling world of quantum chips, with a special focus on Google's latest innovation, the Willow chip. Now, let's talk about Google's latest quantum chip, Willow. Developed by Google Quantum AI, Willow is their newest and most powerful superconducting quantum computing chip. It's designed to learn and evolve, much like the natural world around us. According to Julian Kelly, Director of Hardware at Google Quantum AI, Willow represents a huge step forward. It has increased quantum coherence times by a factor of 5, going from 20 microseconds in their previous chip, Sycamore, to 100 microseconds in Willow. This advancement was enabled by their new dedicated superconducting quantum chip fabrication facility in Santa Barbara, one of only a few in the world. This revolutionary chip is designed to scale quantum computing to new heights, boasting improved error rates and the ability to handle more qubits than ever before. With Willow, Google aims to bridge the gap between experimental and practical quantum computing. It's a glimpse into a future where these machines solve problems previously thought impossible. So, what exactly is quantum computing? To understand this, let's first look at how our regular computers work. Your laptop, smartphone, or even the supercomputers used by NASA all operate on the same basic principle, binary logic. This means they process information using bits, which can be either a 0 or a 1. But quantum computers are different. Instead of bits, they use something called qubits. A qubit can be both 0 and 1 at the same time, thanks to a principle called superposition. This might sound like science fiction, but it's real. And because qubits can exist in multiple states at once, quantum computers can process a vast amount of possibilities simultaneously. This gives them the potential to solve certain problems exponentially faster than classical computers. For example, a problem that might take a classical supercomputer 10,000 years to solve could potentially be solved by a quantum computer in just minutes. So, what does the future hold for quantum computing? The potential applications are vast and varied. Here are a few areas where quantum computing could make a significant impact. If we talk about drug discovery and development. Traditional drug discovery is a lengthy and expensive process, often involving trial and error and relying on physical experiments. Classical computers struggle to accurately simulate the complex interactions of molecules, limiting our ability to predict how drugs will behave in the human body. Quantum computers, however, could overcome these limitations by simulating molecular interactions at a scale and speed unattainable by classical methods, significantly accelerating the discovery of new drugs and treatments. When it comes to materials science, by modeling complex materials at the quantum level, researchers could develop new materials with superior properties. Designing new materials with specific properties is a complex challenge. Classical computers struggle to accurately model the behavior of materials at the atomic and subatomic levels, especially when dealing with complex materials like high-temperature superconductors. Quantum computers, by modeling these materials at the quantum level, could provide unprecedented insights into their behavior, enabling researchers to develop new materials with superior properties, such as superconductors that work at room temperature. Everyone's wondering what the future holds for cryptography with these quantum computers coming into the picture. As you might know, quantum computers pose a significant threat to many of the encryption methods we rely on today to protect our data. These powerful machines could potentially break widely used encryption schemes, leaving our sensitive information vulnerable. However, it's not all doom and gloom. Quantum mechanics also offers the potential for developing entirely new, theoretically unbreakable encryption methods, often referred to as post-quantum cryptography or quantum-resistant cryptography. What will happen with artificial intelligence? Quantum computing has the potential to revolutionize artificial intelligence by dramatically increasing the speed and scale of AI computations. This could enable the development of much more complex AI models that are currently impossible to train on classical computers. Imagine AI systems capable of processing and analyzing vast datasets in a fraction of the time it takes today, leading to breakthroughs in areas like drug discovery, materials science, and financial modeling. Think about weather forecasting. Weather systems are incredibly complex and chaotic, making them notoriously difficult to predict accurately. Current weather models, even those running on the most powerful supercomputers, struggle to capture all the intricate interactions between temperature, pressure, humidity, wind, and other factors. Quantum computers, with their ability to process vast amounts of data and perform complex simulations, could significantly improve the accuracy of these models, leading to more reliable and detailed forecasts. Imagine about the energy. At the heart of many energy technologies, solar cells, batteries, catalysts, lie complex molecular interactions. Understanding and optimizing these interactions is crucial for improving efficiency. Quantum computers, with their ability to simulate molecules at an atomic level, could provide unprecedented insights into how these materials behave. This could lead to the design of more efficient solar cells, by optimizing the materials used to capture sunlight and convert it into electricity. Higher capacity batteries, by discovering new materials with improved energy storage capabilities and faster charging times. More effective catalysts, by designing catalysts that can accelerate chemical reactions involved in energy production and storage, such as those used in fuel cells or hydrogen production. So, how close are we to realizing the full potential of quantum computing? While we're still in the early stages, significant progress has been made. Google's Willow chip is a testament to this progress, but we're not quite there yet. Since launching their first chip, Foxtail, in 2017, followed by Bristlecone in 2018 and Sycamore in 2019, Google has made significant strides. Sycamore even achieved a milestone by performing a computation that would take the fastest supercomputer 10,000 years in just minutes. However, we're still grappling with issues like error rates and the need for error correction. But with Nevin's law, which suggests that the power of quantum computers grows at a double exponential rate, the future looks promising. We're halfway through our roadmap to build a computer with 1 million physical qubits, and we're optimistic about achieving this before the end of the decade. In conclusion, while we're not quite at the stage where quantum computers are solving all our unsolvable problems, the progress is undeniable. With innovations like Google's Willow chip, we're one step closer to a future where quantum computing becomes an integral part of our technological landscape. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more updates on tech and world.